Right, we're going to consider SURDS today as a topic, and then before we proceed to discuss what SURDS is, we need to remember some basic concepts we have learned in JS3, that is rational and irrational number. If you can remember very well, we say rational numbers are numbers that can be expressed as a ratio of two integers in the form A all over B. And we gave some examples of rational numbers to include 2 all over 5, 3 all over 6, 2 all over 7, and the rest of them. And then we also discussed irrational numbers as numbers which cannot be expressed in the form A over B. That is irrational numbers. Example of such numbers, we have 22 over 7, which is the same thing as the value of pi. We have square root of 10, we have square root of 2, we have square root of 5, and the rest of them. Now, someone will say, 22 over 7 is already in the form 2 over 5 or A over B. But the thing is, when you start to divide 22 by 7, you continue to divide without an end. So we have so many examples of fractions that are not terminating, and they are considered as irrational numbers. But those ones that are terminating can easily be expressed as A over B, and those ones are rational numbers. Then to go into the topic for today, which is SURDS, those irrational numbers that are given in the square root form are what we call SURDS. That is, SURDS are square roots of non-perfect numbers, or you can say perfect squares. Now you see, in this example of irrational numbers, I didn't give example like root 4, root 9, because root 4, root 9, root 25 have exact roots, and those ones are not irrational. But those numbers that do not have exact roots are the ones we call irrational. So for our discussion today, we are going to consider how you handle problems that involve all these square root of non-perfect squares, which is strictly what we consider as SURDS. So before we do that, we will look at what we call rules of SURDS. Rules of SURDS. That is, what are the rules, the guides that you need to follow when you are simplifying or manipulating anything that has to do with SURDS. Of course, the first rule here is multiplication rule. When we are multiplying SURDS, how do we go about it? For instance, if I have square root of 36 all over 9, this square root of 36 times 9, this can be split into square root of 36 times square root of 9, and that will give us root of 36 is 6 and root of 9 is 3, and that will give us 18. That is the multiplication rule, which means that when you have two numbers being multiplied together under a single rule, they can be split into two different roots and then multiply. The second one is division rule. And in division rule, if you have square root of 36 divided by square root of 9, you can split it into root 36 all over root 9. And that will mean 6 all over 3, and that is 2. That is 2. You can even check, when you say 36 divided by 9, definitely we get 4. And that means square root of 4 is 2. These are two very important rules when considering SURDS. But you should take note of this. You should take note. When I have square root of 36 plus 9, we cannot say it's the same thing as square root of 36 plus square root of 9. And square root of 36 minus 9 cannot be split as square root of 36 minus square root of 9. Take note of this. Generally now, from the multiplication rule, we can now say that the root of a times b is the same thing as square root of a times square root of b, where a and b can be any positive integer. And again, the root of a all over b is the same thing as the root of a all over the root of b. And from the mod we have here, the root of a plus b cannot be the same thing as the root of a plus the root of b, and so also the root of a minus b cannot be the same thing as the root of a minus the root of b. So we need to be very careful when we are handling sort and follow all these rules. Remember, this is the multiplication of sort and this is the division of sort. So just think, the only thing I want you to take note of here is that you can always split when you are multiplying or dividing, but you cannot split when you are adding or subtracting. And then from here now, let's go to check the next thing that we do under sort. Now, using these rules of manipulating sort, we can always carry out other simplifications under sort. So the next subtopic is simplification of sorts. Now, what does it mean to simplify sort? To simplify sort means you reduce the given sort or the given number under the root sign into a very simple form called the basic form. And then how do we do that? We look for two numbers that will multiply to give you that very number such that one of them is a perfect square. For instance, I have the square root of 48. Square root of 48. Think of any two numbers that can multiply to give us 48 such that one of these numbers is a perfect square, and that will mean 16 times 3. If you look at it now, 16 is a perfect square, 3 is a non-perfect square. And from our multiplication which we have discussed earlier, this can be split into square root of 16 times square root of 3. And of course, the square root of 16 is 4, and the square root of 3 is not a perfect square, so it's going to be 4 root 3. 4 root 3. Now, 4 root 3 is the basic form of square root of 48. Let's take another one. I have square root of 250. Square root of 250. What are those two numbers that will give us 250? We have 25 times 10. Check this one too. 25 here is a perfect square. 10 is not perfect square. And this can be split into root 25 times root 10. What is the root of 25 now? 5. So we have 5 root 10. Therefore, the basic form of root 250 is 5 root 10. Let me ask you a very simple one. We have square root of 12. How can you change this one to its basic form? Let me give you just 1 minute to try this as we come back and then take it over. I hope you are trying it. Okay. You will check 12. You have 4 times 3. Is that what you have? Alright. So this will be square root of 4 times square root of 3. What is the square root of 4? 2. And 3 is not a perfect square. So the basic form of 12 is 2 root 3. Have a look at this. When you go into other simplifications, you need this to understand how you either add or subtract sorts. Now, we can also take the reverse of 4 root 3 to get root 48, 5 root 10 to get root 250, 2 root 3 to get root 12. And when we do that, we are trying to change it to the root of a single number. How do we do this? Let's check the first one. We have 4 root 3. We want to write 4 root 3 as the root of a single number. Of course, if you look at this and you begin to wonder, how do I do this? How do I do this? What you do now is that you square the number outside here. That is the number that is not under the root, and then you multiply it by the one inside the root. And that will be, when you square 16, 4, you get 16. Then you multiply it by this 3. And then 16 times 3 will give you 48. That is the reverse. Are we there? Let's check 5 root 10. 5 root 10. What are we going to square in this case? Is it 5 or 10? Of course, we square 5. And that will mean 25 times 10. And then if you square this, you multiply this out, you get 250. And the last one, I believe you can do that. But can you try that and tell me how you do it? Okay, definitely we square 2. And when you square 2, you have 4. And then the 4 will have to multiply this 3, which is already under the root. And that will give us root 12. Let me give you one simple one. How do you change 3 root 7 to its basic form or to the single root form? Do we square 3 or 7 here? Of course, we square 3. And that will mean if you square 3, you get 9. And 9 times 7. And 9 times 7 will give us 63. 63. And that is just how you take the reverse of changing from basic form to the root of a single number. With this understanding, we will now proceed straight to how you can add and subtract SURDS. So we have addition, and subtraction of SURDS. That is, we are now taking the arithmetic operation concerning SURDS. Now, how do we add or subtract SURDS? In adding and subtraction of SURDS, we only add similar SURDS, just like we add like terms in algebraic expressions. And we can also subtract similar SURDS. Now, what do you mean by similar SURDS? Similar SURDS are SURDS that have the same number under the root. As similar SURDS have the same number under the root. That's under the square root, and the number under the root is called the radicand. For instance, 3 root 2 minus 2 root 2, 1 over 3 root 2, and the rest. All these are what? Similar SURDS. What is the number under the root here? We have 2, 2, 2. So these are called similar SURDS, and therefore you can add or subtract them in any given expression. But if I have 3 root 2 and 2 root 3, can this be similar SURDS? No, these are not similar SURDS. Reason being that here the number on the root here is 2, and the number on the root here is what? 3. So you cannot add or subtract these ones. Somebody will say, what of 3 root 2 and 3 root 3? Remember, we only consider the number under the root. The number under the root, but not the numbers before the root. So that you don't confuse yourself and say, okay, since I have 3 and 3, then they are similar SURDS. No, they are not. So these ones are not similar SURDS. And as I said before, we can only add or subtract what? Similar sorts. So let's take for example, I have let's take examples. 1. Simplify the following. Simplify the following. I have a root 96 plus root 54 minus root 24. B root 12 plus 10 root 3. And let's take just 3 for now. And as I said before, when you are simplifying similar sorts, just the way you collect like terms in algebra, you also do the same thing here. So the first example there we have is now 96, of course, is the same thing as 16 times 6. Now you check, 16 is a perfect square, 6 is not. 54 is the same thing as 9 times 6. 9 is a perfect square. And then 24 is the same thing as 4 times 6. 4 is a perfect square. So that means this is very simple now. So that we can write this as square root of 16 times 6 plus square root of 9 times 6 minus square root of 4 times 6. Alright, so from our previous lesson, we discovered that this can also be splitted, this can be splitted, this can be splitted. So we don't need to be doing all those things all through. All we know is that the root of 16 here is 4, and then under the root of 6, because we can't take the root of 6 since it's a perfect square. Here, the root of 9 here is 3, so you have 3 root 6, and then the root of 4 here is 2, so you have 2 root 6. Now you see everything now is having root 6, root 6, root 6. So all of these are what? Similar sorts. And therefore, we can add and subtract as the case may be. How do we now do this addition and subtraction? We can only add the coefficients. So don't come and say 4 root 6 plus 3 root 6, then you say it's going to give root 12. No. But you only add the numbers before the sorts. Okay? So here, the number before this sort is 4. The number here is 3, and the number here is 2. So we can only say 4 plus 3, which is 7, and then 7 minus 2, which is 5, and then root 6. That's just that. Please take note. This means 4 of root 6 plus 3 of the root 6. So if you have 4 root 6 and I add for you 3 of the root 6, you have 7 of the root 6. And then I now take away 2 of them. You will left with how many root 6 now? 5 root 6. And there's nothing you can do here any longer. You can just finish simplifying it. The second one, we have 3 root 12 plus 10 root 3. 3 root 12 plus 10 root 3. Now, look at this. This 12 can be splitted, but this 3 cannot. Remember, our interest is the number under the root sign. Now, how do we split 12? We've done that before. So we are going to have 3 root 4 times 3 plus 10 root 3. Now, when you take the root of this 4, which is 2, you come up with this 3, which is already here. So we are going to have 3 times 2 root 3 plus 10 root 3. 3 times 2 is 6 root 3, and now plus 10 root 3. 6 here is root 3, here is root 3, that means they are what? Similar sorts, and we can now add 6 root 3 and then plus 10 of the root 3 will give us 16 root 3. Then the last one here, we have root 32 minus root 98 plus 5 root 2. Okay? Now if you check 32, it's going to be what times what will give us 32? 16 times 2. 98 will be what times what? 49 times 2. And then this 2 is already, this one is already in basic form, so we don't have a problem here. So we'll just express this one as square root of 16 times 2 minus square root of 49 times 2 plus 5 root 2. Then what is the square root of 16? We have 4 root 2. Square root of 49, 7 root 2, and plus 5 root 2. So to be on the safer side, we can add before subtract. And that means I will have 4 root 2 plus 5 root 2 minus 7 root 2. 4 root 2 plus 5 root 2 is 9 root 2. So we have 9 root 2 minus 7 root 2. I have 9 of root 2 minus 7 of root 2. Then we say 9 minus 7, which is going to give us 2 and then root 2. And that is just what we have here. I hope you are following. Right? So we'll proceed from here. Then later on we'll take general exercises to cover each of these things that we have touched. So we are going into the next arithmetic operation, which is multiplication of SURDS. Multiplication of SURDS. Now, to multiply SURDS, 1. To multiply SURDS, we first of all simplify into basic form if possible. Then secondly, we group the numbers together and the SURDS together, and then when you do that, then finally you want to multiply out and simplify if possible or where necessary. So when you are multiplying SURDS together, the first thing is what? You break them down. After breaking it down, then you group them, that is the numbers together, you multiply them, and then the roots, the number one and the roots together, you also what? Multiply them. And if what you have needs to be broken down to, then you also do that. Example, simplify the following. A, let's go like this, root 9 times root 16. B, root 50 times root 48, and then C, root 25 times root 12 times root 40, 75 and 75. Right? Good. Solution. Now, the first one, we have root 9 times root 16. Now, 9 and 16 are already perfect squares, and we don't have much problem with this. So we just say, what is the root of 9? 3. What is the root of 16? 4. And then we just say 3 times 4, 12. Very simple as ABCD. Then the second one, we have root 50 times root 48. Now, if you check 50 and 48, they are not perfect squares. And therefore, you simplify into basic form, if possible. That means we can simplify 50 into the basic form, and then 48 into the basic form, then we now carry that out on the multiplication. And 50, of course, we know is 25 times 2, then times 48, of course, we know is 16 times 3. And therefore, the root of 25 here is 5. We have 5 root 2 times 4 root 3. And we have now simplified it into their basic form. So the grouping now is that 5 and 4, you group them together so that they can now multiply each other since they are not under the root. And then 2 and 3, that's the 2 and 3 will now come together like this. And we have 5 times 4 is 20, so we have 20 root 6. Simple. Simple. Okay? Then the next one we have is square root of 12 times square root of 75. Now, what is square root of 12? 12 is not a perfect square, and then 75 is not also a perfect square, so we also have to what? Simplify it. And that means 12 is 4 times 3, and times 75 is 25 times 3. Now, what is the square root of 4 here? We have 2 root 3 times the root of 25 here. We have 5 root 3. So we'll now check it out. What do we group together? 2 and 5. And that means I'll have 2 times 5. And then times root 3 times 3. Because we have root 3 here, we have root 3 here. Now what is the root of, what is 2 times 5? 10. 3 times 3 is 9. And you see in this question, 9 is already a perfect square. So do we leave it like this? No. And that means we have 10 times 3, and that will give us 30. So this is how we can multiply sorts together. But then, let me give you one example too. Let's say you have, let me add D. Let's say you have 2 root 7 squared. You know this is also multiplication, right? Okay. Now, this one means I'm going to have 2 root 7 times 2 root 7. That's to say that if it were power 3, now I have to multiply it 3 times. It is power 5, multiply it 5 times. It is power 100, you multiply it 100 times. Is that okay? So now, this one will definitely mean I will multiply this 2 and this. That is 2 times 2, and then 7 times 7. And then 2 times 2 is 4. Root 7 times 7 is root 49. And of course, 49 is perfect square. And that root of 49 is also what? 7. And that will give us 4 times 7, which is 28. Which is 28. Okay? Now, if you look at this, it's very simple. That means that if I have 2 root 7 like this, then I can quickly just square this 2 and then cancel this root. By the time you square this 2, you get this 4. Right? And by the time this square cancel this root, you'll be left with what? 7. And then 4 times 7, you have 28. Is that okay? Good. So with this, we'll now go into division of SURDS. Remember, I told you sort is all about addition, subtraction, multiplication, and division. And it's always straightforward. Now, just as we have explained for multiplication of SURDS, to divide SURDS, you also first do the first part. That is, first step is that you simplify the SURDS if possible. You simplify the SURDS if possible. Now, after you have simplified the SURDS, then the next thing is that is division. So you divide numbers. Divide numbers as a group and SURDS as a group. That is, you group the numbers together just as we have grouped in multiplication, and you divide them. You also group the ones under the root together, and then you also divide them. And then finally, you now simplify the answer. Simplify if possible. But in doing this, there is something you should take note of for division. If what you have as your denominator is still carrying a root, then you have to what? Rationalize the root. Okay? That is, you do away with the root. So you should take note. Then we rationalize. Right? How do we rationalize? I want us to understand that very part first before we proceed, so that when it occurs in our problem, we can always handle it. Simply means I will multiply this by the 3 and also multiply this by the 3. So 2 times 3 will give us 2 to 3. And then root 3 times root 3 will give us root 9. Right? And then, of course, 9 is perfect square. So we are going to have 2 root 3, and the root of 9 is what? 3. So we have just rationalized this. Okay? When we say to rationalize means you do away with the word root in the denominator. In answer, we no longer have roots under the denominator here. Okay? Let me give you this one to try. You have root 2 all over root 5. How do you rationalize this? You still use the roots in the denominator and multiply both numerator and denominator by it. That's to say, I'll multiply this one by root 5 and then this one by root 5. So root 2 times root 5, from your knowledge of multiplication, we are going to have this as root 10. Because these two will multiply this 5 since we are under what? Root. And then this will multiply to give us root 25, and that is going to be root 10 all over 5. Okay? So this is the concept of rationalizing the denominator. So we'll pick some examples and then see how we can simplify. Example, simplify the following. A, let's say I have 4 over 16. B, I have 300 all over 50. C, I have 25 all over 3. let's take just 4 for now. I'll have root 2 times root 5 all over 3. Alright. The first question here is root 4 all over 16. Now, from the rules of sorts that we've discussed earlier before now, you see this can be split into root 4 all over root 16. And the root of 4 is what now? 2. Root of 16 is 4. And this can be 1 all over 2. Okay? The question we have here is root 300 all over 50. Now, the first thing is that we express 300 to be what? To be in its basic form. And what are the two numbers that we multiply to give us 300? So that one is a perfect square. Of course, 100 times 3. And then we have all over 50. And the root of 100 is 10. So we have 10 root 3 all over 50. So you see, the denominator here does not have a root, so we are okay. And this can be simplified into, say, 10 here 1, 10 here 5. So we have 1 all over 5 root 3. And we are done. The next question is square root of 25 all over 3. And then from our rules for manipulating sorts, this can be split into root 25 all over root 3, and that will mean 25 is a perfect square, and the root of 25 is 5 all over root 3. So you see, this is where we now have to what? Rationalize, because we can't leave this root 3 in the denominator. And then how do we rationalize? As explained earlier, we will multiply both the numerator and the denominator by root 3. Okay, so 5 times root 3 will give us 5 root 3. Root 3 times root 3 is root 9, and 9 is a perfect square, and that will give us 5 root 3 all over 3. And then the last one here, we have root 2 times root 5 all over root 3. Of course, this can be multiplied to give us root 10 as 2 times 5, and then all over root 3. And in this case, we also have to what? Rationalize. We multiply this by root 3, multiply this by root 3. So root 10 times root 3 will give us root 30. Root 3 times root 3 will give us root 9, and that is root 30 all over 3. Now if you look at it, 30 does not have a factor that one of them is a perfect square, and therefore we can leave it as it is. But assuming we have something like root 50 over 3, of course we will have to break the root 50 down to its basic form before we leave it like that. So that is that on division of sorts. But before we finally stop as we course this one, let's take one more example that will involve all the basic concepts. Let's say example 2 that involves division of sorts.
That's okay.
Let me just give you 2 here. 8 root 48 minus 9 all over root 3 plus root 75. The B part is 10 all over 4 root 8 minus root 18, minus 7 root 8. Okay, solution. Now the first question here, we have root 48 minus 9 all over root 3 plus root 75. We first of all express root 48 and root 75 in the basic form. And root 48 is 16 times 3 So we have 9 all over root 3 plus 75 is 25 times 3. The root of 16 is 4, so you have 4 root 3 minus 9 all over root 3 plus the root of 25 is 5, so you have 5 root 3. So you add before we subtract. 4 root 3 plus 5 root 3 will give us 9 root 3. Okay, that is 4 plus 5 is 9. Then you have minus 9 all over root 3. So at this stage, you take LCM or you rationalize this before you take LCM. So let's take the LCM of 1 and root 3, which is root 3. So root 3 divided by 1 is still root 3, then times 9 root 3. We'll have 9 root 9 here. Okay, then minus root 3 divided by root 3 is 1. 1 times 9 will have 9. And therefore, 9 root 3. 9 times root 9 is the same thing as 9 times 3. Since the square root of 9 is 3, then you have minus 9 all over root 3. Now, 9 times 3 is what now? 27. So I have 27 minus 9 all over root 3. Then you now check and you go that this 27 and this 9 can be subtracted directly since they are not under a root. So what is 27 minus 9? 27 minus 9 will give us 18. So we have 18 divided by root 3. Okay, so at this stage now we can't leave the answer like this. So we have to rationalize by multiplying the numerator and the denominator by root 3. And that means we have 18 all over root 3 times root 3 all over root 3. So 18 times root 3 will give us 18 root 3. Root 3 times root 3, of course, is square root of 9 and it's the same thing as 3. And if you check it, since this can be simplified, that is 18 can divide 3 6 times. So the final answer will be 6 root 3. That is that for this. Then the second question here, we have 10 divided by 4 root 18 minus 7 root 8. The same thing we'll do here. 18 and 8 will express them in their basic form, and this will give us 10 all over 4. 18 now is going to be what now? 9 times 2. Then minus 7 root 4 times 2. And this will give us 10 all over. The square root of 9 is 3, so the 3 will multiply this 4. That's why 4 times 3, then root 2 minus the root of 4 is 2, and the 4 will multiply this 7, and that will be 7 times 2 root 2. So we'll have 10 all over 12 root 2 minus 14 root 2. Now, 12 root 2 minus 14 root 2 are similar sorts, so we can subtract. And you know, this is something as saying 12 minus 14. And 12 minus 14 is what? Minus 2. So what we now have is going to be 10 all over minus 2 root 2. And of course, 2 here is 1, 2 here is 5. So we're going to have minus 5 all over root 2. And again, we have to rationalize the denominator. And that means minus 5 over root 2 times root 2 all over root 2. And this gives us minus 5 root 2 all over root 4. And root 4 is what? 2. And that is the final answer you have here. So to round off this lesson, we'll take some exercises and then you give them some trial. So number 1, exercises. Number 1, simplify the following. A, I have root 180. B, root 396. C, root 4p square q, and then d root 720. Then the second one, you have to express the following as square root of a single number. A 4 root 2, B 7 root 7, C x squared root k, D 5 root 13. And then the third one, you simplify the following. A is 2 root 147 minus 9 root 192. B, we have root 8 plus 4 all over root 2. C, root 128 minus 2 root 72 plus root 32 plus root 8. And then D, 3 root 12 plus 10 root 3 minus 6 all over root 3. Then the last one is going to be 3 all over root 3 into 2 over root 3 minus root 12 all over 6. Good. So try these ones on your own. They are quite simple and straightforward. Thank you and have a nice day.